reviewing Unit 4 today, which is chapters 14 through 17, and this is the probability unit. I know that there is a lot of stuff going on in this unit, okay? It's going to be on the AP exam. It's going to happen. Now, we answer lots of probability questions in other units. So in Unit 1, we use the normal model. We can use normal CDF, and we can find probabilities that way. In Unit 5, and Unit 6, and Unit 7, we're finding probabilities when we find the p-value, when we use normal CDF and TCDF and all of those things. So we can find probabilities in other ways, but this is the chunk of probability we need to make sure we remember. So, 4 chapters. Started off, the first half was like basic probability things you guys learned in Algebra 2. Then we went into a little more complicated, different statistical probability type things. So, Chapter 14, basic probability rules. This is the stuff that you guys already knew, for the most part. A probability is a number between 0 and 1. Do not miss questions because you aren't paying attention. If they give you probabilities that don't add up to between 0 and 1, then they aren't disjoint. That means there's something in common between them, and you need to make sure you take that into account. The set of all possible outcomes must have a sum of 1. Like I said, all of your probabilities all together have to add up to be 1, so make sure that you are looking into that. The complement rule. The probability of an event occurring is the same as the probability of 1 minus probability that it doesn't occur. We use this a lot of the time when we're trying to answer questions involving terms like at least. When I want to say, I want to draw at least 5 green M&Ms out of the bowl, well then that, if there's 100 M&Ms, that might be hard to compute. Because at least 5 means 5 or 6 or 7 or 8 or 9 or 11 or 12, right? So at least we want to use 1 minus the probability that you don't get 5 green M&Ms. All right, so different ways to do that. But keep that in mind. We use that rule a lot, actually, in Chapter 17. Disjoint or mutually exclusive events. Disjoint and mutually exclusive mean the same thing. Make sure you know both terms. These events have no outcomes in common. For example, if I was going to ask the probability of being a senior in high school or a junior in high school, you cannot be both a senior and a junior at the same time. So they're disjoint events. So no outcomes in common. The probability that one or the other occurs is the sum of the probabilities of the 2 events. So make sure you know this notation. The U stands for union, and it means A or B. In this case, if you have disjoint events, then the probability of A or B is the probability of both of them added together. We're going to build on that rule in a second. Independent events. We've talked about independence enough in this class, so hopefully you understand what independence is. But independent events have no influence on each other. And the probability that both events occur is the product of the probabilities of the 2 events. All right, so as long as they don't influence the other, then you can just multiply the probabilities together. So I want to know the probability of drawing a green M&M out of a bowl and then drawing a blue ball out of a bag of 10 different colored balls. Then those don't have any weight on each other. They don't influence it. They're completely different things. But I want to know the probability of getting both of those. Then you have an and situation. That upside down U means intersection. That means and. Probably both of those actually happening at the same time. You would just multiply those probabilities together. Again, this would be independent, where they have no influence on each other. That's basic probability rules. You guys knew most of those. Keep those in mind. Those aren't going away. Don't miss an easy question because you're overthinking it, too. That happens a lot on the AP exam. In Chapter 15, we're talking about more complex probability rules. So, here we're going to build on some things and talk about things on the AP formula sheet. The general addition rule is on the AP formula sheet. And it says the probability of A or B, again, that U means or, is the probability of A plus the probability of B minus the probability of A and B. So we just talked about this 5 seconds ago. Like if disjoint events, the probability of one or the other occurring is just adding them together. Well, what if you have events that aren't disjoint and you want to figure out the probability of one or the other happening? Well, then you have this formula. We did a lot of questions in the book they're about houses for whatever reason. So the probability of having a garage was this. The probability of having a pool was this. And so what's the probability of having a pool or a garage? Well, you add together the probabilities and then you take out the overlap. And that's what this part denotes. Right? That formula is on the AP formula sheet. Know that it's there and look at it, and then maybe you can use it. I also personally use Venn diagrams in lots of these questions. That way I have a visual. If you're using a Venn diagram, then you don't have to use the actual rule because you've already taken into account the overlap. Okay? Conditional probability. This is also on the AP formula sheet. The probability of A given B. So they're defining something for you. The probability of one event occurring, given that the already is occurring. You have the probability of A and B divided by the probability of just B. So, again, it's on the AP formula sheet. Use that. When it says something is given, know it's conditional. A lot of the time, you're given a contingency table in this case, and you may not need to use the formula. So that's where you had two-way tables, and it said, for example, one side said what year, like what class you were in high school, so freshman, sophomore, junior, senior. And then the top part said like what sport you most like to watch on TV or something. And so then if it's asking you a conditional question, normally you can narrow that down just by looking at the contingency table. You can also write the general multiplication rule, which works when events aren't independent. So we had a rule up here for independent events. The probability of both of them occurring at the same time, which is multiplied together. If they're not independent, then you can rewrite the conditional probability rule just by multiplying. If you cross multiply, you get the probability of A and B equals the probability of B times the probability of A given B. So you can manipulate those formulas as well. Make sure you look at the formula sheet when you're doing probability questions in case you need it. We also talked about independence. The probability of A given B, if that's equal to the probability of A, then you have definite independent events because the condition doesn't matter. Other things from this chapter, drawing without replacement. So that means if you were doing probabilities with cards or something, or you were taking marbles out of a bag and not putting them back, that kind of thing. So if I want to know the probability of drawing 3 queens in a row, well, the first time it's 4 out of 52, but the next time you've already drawn 1 queen and taken out a card from the deck. So then you have 3 out of 51. So make sure you think about those things. Think about the scenario. Do you need to make sure you're reducing those probabilities each time? And then tree diagrams. If you have a complex problem that's kind of like an if-then problem, like if this happens, then this happens, and if this happens, that means this happens. Tree diagrams can be pretty helpful. If you multiply across the branches, you can use those to find answers to your questions most of the time. So keep all of those things in mind for basic probability. I know it's all going to jumble together, but if you know some of it, you'll probably be on a good track. Now, chapters 16 and 17, this is where things got tricky. These weren't just basic probability questions you've been doing in algebra classes before. Chapter 16 is about random variables. Random variables was just where we defined an event with a variable. So X is drawing a card, or X is playing a carnival game. Okay? You had probability models. The phrase probability model is just a fancy way to say make a table. The table includes all the possible outcomes of the event and the probability that each of those would occur. We did a lot of those in chapter 16. Based off of the model, you should be able to calculate the expected value, which is just the mean, the variance, and standard deviation. The expected value is on the AP formula sheet. It's EX, which is the same thing as the mean. It's the sum of all of the outcomes times their probabilities. It always needs to be calculated by hand on a free response. Show your work. It doesn't take that long. They're looking for the calculation. The variance, sigma squared, also on the AP formula sheet. Here's what it says to do. You take every outcome and you subtract the mean that you came up with. This is the mean, so you have to find the expected value first. So you find the mean, you subtract those values, you square them, multiply that value by the probability of that specific event, and then repeat that process for every outcome and add them all together. That gives you the variance. If you want to find the standard deviation, then you take the square root. Remember, the square root of the variance is the standard deviation. Alternatively, the standard deviation squared is the variance. Keep those things in mind. You can do that by hand, but I also showed you how to do that in your calculator. So it tells you how to do it down here. But in case you forgot, go to your lists, so stat edit. You'll have some stuff in list 1 and some stuff in list 2. All right, these are just arbitrary numbers that are in here for some other reason, so that's not really important right now. But you have something in list 1, something in list 2. You have list 1 should be all of your outcomes. So let's say it's like your winnings in a carnival game. And list 2 should be the probability they occur. Then you go to stat, calc. You're still doing one variable statistics. List 1 should be the list you're using, and list 2 with the probabilities should be the frequency list. And then you hit calculate. X bar is the mean. This is the expected value. You already should have found that, but this is a good way to check your answer. Then they give you sigma x. This is the standard deviation. And it does the work for you. Like if they ask for the variance, they'll need to square that value, because that's the standard deviation. Okay? But you can do that in your calculator. Now here's where things got dicey. We had rules for random variables. We talked about this in Unit 1, and I reviewed it recently in Unit 1. But in Unit 1, we talked about if you start shifting data or if you start rescaling data, what happens to the means and standard deviations? When we shifted data, the means changed, but the standard deviation stayed the same. When you rescaled data, then everything changed. We are using similar ideas here for the rules for random variables. I split it up into expected values, standard deviations, and variances. Expected values. Do whatever it tells you to do, because expected value is just the mean. So if it says you should multiply by 5, then go ahead and multiply the mean by 5. If it says to add 3 to the mean, then you should add 3 to the mean. If it says you should add or subtract 2 means together, then you should do that. There should be no question what to do with the mean, because you can do whatever you want. With standard deviations, it's a little bit trickier, though. All right, first of all, if you're supposed to multiply, you can multiply. We said that back in Unit 1. Standard deviations change when you rescale data. That means when you multiply or divide all the data. So you should do that. But if it says to add or subtract some constant, if that means you're shifting the data from one side or one way or the other, if you're shifting the data, that doesn't change the spread of the data. The shape is going to stay the same. So you do not add constants. That's very important. We talked about this already once. I'm saying it again. Also, notice there is no rule about adding standard deviations together. You cannot combine standard deviations. You can't do it. If it says there's a standard deviation for one event over here and the standard deviation for the other event over here, you can't add them together. Okay? If you do need to combine standard deviation to get a new standard deviation, then you have to combine variances. Okay? So you'll have to take your standard deviation and square it for both groups, and then you always, 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 always add variances. Right? You don't subtract them. Again, if you want to find the standard deviation, you would just take the square root of that amount at the end. The rules for multiplying and adding are similar for variances. You don't add constants, right? You just leave it alone because variance is still a measure of spread. Since the variance is the standard deviation squared, if you're asked to multiply the variance, then you should square that multiple before you multiply. Right? So be careful with those. They're going to try to trick you with the adding constants part and the always adding variance part, generally. Okay? And then lastly was chapter 17, the geometric and binomial models. Both models are based on Bernoulli trials, where you had two possible outcomes and two possible outcomes only, success and failure. The outcomes had to be independent, and the probabilities had to remain constant. That means they weren't changing over time. So the first model was the geometric model, and that was the probability that the first success is on or in a specific number of trials. So if I asked you, what's the probability that someone makes their first free throw on their 5th attempt? That is a geometric model, right? You'd use geometric PDF to calculate that if you wanted to. You have a probability and then a specific trial number. So these are all in your distribution menu, if you remember. Scroll up, you've got geometric PDF and binomial PDF and CDF. So PDF asks you for P, which is the probability of success, and then what trial number you want your first success to come on. Okay? Geometric CDF, you're looking for the first success within a certain number of trials. So what's the probability he makes his first attempt in the first 5 attempts? That kind of question is CDF, cumulative. Remember, the C stands for cumulative. Again, P is the probability of success. They're going to ask you what's the expected number of trials until the first success. And that is 1 over P. You need to know that one. The second model is the binomial model. That's the probability of successes out of a specific number of trials. So binom PDF, if I ask you what's the probability that someone makes 5 free throws out of 20, that's the number of successes out of a specific number of trials. That's binomial PDF. They get more complicated when you have CDF. It's cumulative. So what's the probability that he or she makes at least 7 free throws out of 30? Remember, at least means you're adding things together. So that's multiple probabilities you need to add together. So at least you would do 1 minus the probability of getting 6 or less. Remember, cumulative adds up from 0. They might also ask you for the expected number of successes out of a number of trials. That's n times p. And if they ask you the standard deviation for those successes, it's the square root of npq. Both of those are on the AP formula sheet. Hopefully I've jogged your memory a little bit. Some things to be thinking about. But you can find all the information in chapter 14 through 17.